So y'all already did surface area of all the other figures, but y'all didn't do it for spheres. So I don't know why the book does it, but they tied it in with volume. Okay. The spheres, remember, is any ball. Okay. Any 3D figure, round. Yeah. Okay. I don't know what a ball is. So we're going to go over that. It's actually a really easy formula. You don't have to memorize it. Okay. So here we go. Y'all know what a sphere is? Here's the geometric definition. A set of all points, a given distance from a given point. So just think of a gazillion, trillion, infinitely many points, the same distance every which way from that one little point to the center. And that given point is called the center. It's like the circle, call that circle the center. So it's a little bit better. So the sphere is also going to have a radius. Okay, that's that distance from the center to any point on the sphere. There's also a chord that can be inside the sphere. That's a segment with both endpoints on the sphere. And then the diameter is also in a sphere, and it's basically a chord, but it has to go through the center. Okay, so it's very similar to the circle, just think 3D now. Make sure you draw a radius. That's what I already drawn for you, but they didn't draw the chord and they didn't draw a diameter on your picture, so do that on your notes page. Okay, I know you may know it, but did you do that when during the surface area? You did? During, oh, yeah. That's good. Okay. Let me see this one here. Yeah, surface area. So we'll write that on there. Okay, anybody still writing these? Okay, so let's go over the definitions now. Okay, for volume, it's going to be 4/3 pi r cubed. 4/3 pi r cubed. There's a blank for that one. Sorry, there's not a blank for surface area, so just add it on there right next to the volume formula. 4/3 pi r cubed. Why do you think r is cubed now? Because it's 3D now. Remember the units now that we're doing volume is in cubic units. Remember all the little cubes at the inside of figure? Okay. So the surface area, the area of a circle is pi r squared. Go get water now. Go. I don't want you coughing the whole time. Okay, surface area now. Okay, by the way, what units is that in? Squared units. So what do you think that one's going to look like? 4 pi r squared. So I don't remember this one last time. Okay, so like I said, you don't have to have it memorized. Just be able to know how to use them, which we're going to go over right now. Everybody got them down? Okay, so this first one, that one's on there. I'm going to read my answer in terms of pi on the first one, just because I think it's easier. And then if you want to go change it to decimal answers, you can. Okay, so for volume, it's 4/3 pi r cubed. Okay, and so it's real simple. All you have to do is put 4/3 times 4 to the third in your calculator, and then voila, it's in terms of time. So what is it? Do I know how to find the cube at, yeah? Yeah, or you can do the caret and the 3. So what is it? 80 what? 85 and a third pi. Is that what y'all got? Did y'all get 85.3333? Yes. Who did not? You got the whole decimal? All I wanted was just those two numbers. Yeah, just those two things. And that's leaving it in terms of time. Some of y'all struggled, by the way, leaving it in terms of time on your quiz. Which wasn't too bad. I'll go over that maybe. I don't have everybody's grade, but if I have time, I'll try to finish up during class while you're working on your assignment. That's it. That's right, millimeters cubed. Don't forget the units, because we're in cubic units. Okay, over here, surface area. That's a simpler formula. 4 pi r squared. Same thing, just put, or you can multiply that in Henry. What is that? 36 pi. Right? And it's inches squared. Okay. And again, if you want to put it in decimal, all you have to do is go put in your calculator 36 times pi. Pi's at the bottom, right? Bottom left corner? Something like that. Okay, so easy, right? Easy formula? All right, let's go to the next one. Wow. I don't see it as a second page. No, it's the surface area formula. I just realized that. Sorry. Second page has the surface area formula. I said write it on the other one, so just write it again over there. Sorry about that.
Wait, we go back.
No, it's right there. Okay, the area of the base of a hemisphere is 225 pi into square to the area. That's wrong. This is not square. Okay. What is the volume? Okay, so what's the hemisphere look like? Like a dome, half of a sphere. Good. So I'm gonna try to draw it. So just draw like an oval, and then draw something like that. There you go. Right. Okay. All right. And then we have a radius. We don't know what that is, but we can probably figure it out. Okay. So what's the volume formula again? 4/3 pi r cubed. But what do we want to do to that? Divide it by 2 or multiply by half. I'd rather multiply it by half just because it looks easier when you multiply fractions. Okay, because if you divide by 2, then sometimes I don't know how to, yeah, we'll see like that. Having a fraction in a numerator looks kind of difficult. Okay, so we're going to do that, which makes it easy because what's half of 4/3? 2/3, right? Okay, so 2/3 pi r cubed. So this is the formula that we want to work with for that guy right there. 2/3 pi r cubed. Okay, and then we don't know the radius, but we can solve for it because it did give us the area of this circle right here. So if it gave us the area of that circle, we can do pi r squared. Is that the formula for area of the circle? Equals 225 pi. Okay. What's the first thing you should do? Huh? Divide both sides by pi, or just cancel them out. Whenever you see a pi on each side, they cancel out. Okay. Here's what some of y'all made a mistake of on your quiz. You want to take the square root first, which is wrong. Okay. I don't know if you remember doing that, but these got to go first. Then you've got r squared by itself. You can't take the square root of something to the very, very end until it's by itself like that. So now square root. So now take the square root and what is r equal? R is the thing. Now plug R into there. And so you'll have 2/3 pi 15 cubed. Go ahead and multiply just those two in your calculator. Let's leave it in terms of pi. Make sure you're putting 2/3 in parentheses like a fraction.
2/3. 2,250.
Just add a 0. And then what's your next? And there's your answer. Okay, so you have to do a little bit of work to solve for the R, and then it was only half of a sphere. All the end of it. All right, okay? Where? Word problem. Again, I'll struggle with the word problems because it deals with a lot of reading. It says, lobster fishermen in Maine often use a spherical buoy to mark their lobster traps. Every year, the buoys must be repainted. An average buoy has a 12-inch diameter, and an average fisherman has about 500 buoys. A quart of marine paint covers 175 square feet. How many quarts of paint does the average fisher need each year? Okay. What is this symbol? Surface area. Whenever you hear painting, it means we got to do surface area. So remember, buoys are like spheres, right? And they're like red on top, right? Yellow new fishermen here, boys. And some girls, yellow fishermen, your dad. Leathers. So they're like red out there, and then we got to paint them. So surface area is easy, 4 pi r squared. Okay. Okay, so it says that the diameter, right, is 12 inches. Okay, so from here to here is 12 inches. So what's the radius? 6 inches. Okay, what do we need to do here? Because right now I'm already thinking of something that I don't think y'all are. What do we got to do? Convert. Why? Why do we got to convert? Yes, the paint is in square feet, and so you should change it from the very beginning. So what's the radius, Alyssa? I mean, Allison, sorry, I don't know what I did with that. 1/2, right? So let's put 0.5, and now it's in feet. Okay, so you want to work with that one. All right, so let's find one. So 4 pi 0.5 squared is 0.25. Let me just write that down right because 5 squared is 4 is 1 pi, right? Okay, so the surface area of one buoy is 1 pi. Let's leave it like that, okay? Because I know you're probably going, oh, that's just funny, that's 3.14. Just leave it like that because it's more accurate, okay? So that's 1. And then how many do we have of these? 500. So let's times it by 500, which is what? 500 pi. Good. So that's the total surface area that we have to paint, okay? Total. So now what do? Yeah, put 500 pi in the calculator, and then what? Yeah, and then divide it by 155. Because then that will tell us how many quarts we need. So put 500 pi, divided by that, what do we get? Everybody said it over here. 7 something. Quarts, right? And then I'm pretty sure you have 5.97 of a quart, right? So you want to just go ahead and round up. So how many quarts are we going to need? 9 quarts. There we go. So anytime it's a real world problem like that, let's say it was 0.2. Can you buy 0.2 of a quart over there? No, you've got to buy the whole can of paint, the quart. Okay? So you got to round up, even though 0.2 kind of means round down. In real world, you would want to go up. Okay? Because then you think about it, you go to Home Depot right now, you got to paint your room, and I'm going to round down, you're going to have paint missing in the corner. Yeah.
For averages, if there is an average of 2.5 families in the
that one is why it's asking for an estimate. Like, you always want to probably have more if you're like doing food, catering or whatever. And, yeah,
I don't want it.
all right, that's it. Okay, so I think we want to skip a couple of things, because we already did surface area, so we'll just skip those, so it's pretty easy. All right, we give you your assignment in a second after.